Hello Pre-Calc PC. Today we are talking about application of 3D vectors, specifically our directional angles. So if we take a look at this, we already know 3D vectors are in, well, 3D space. So we have our x, our y, and our z axis. So what we're going to talk about today is how to find the vectors or the angles between the x, y, z axis and our vector. So first off, we're going to call alpha the angle between the vector and the x-axis. So here's your x-axis right here, and you can see alpha is our angle. There's vector v. I'll put this in a different color. This red arrow here. Okay, and then beta we're going to call the angle between the vector and the y-axis. So here's my y-axis. All right, and again, just this might be shifted a little differently than you're used to, but here is angle B or angle beta. And then finally you have gamma, which is the angle between the vector and the z-axis. So again, here's your vector, the red arrow, and there's that angle. So basically what we're going to do is we're going to find those three angles. And it's actually really easy to do. You're just going to find the cosine of alpha, you take your a value over your vector, the magnitude of your vector. Your cosine beta is your b value over the magnitude of your vector, and your cosine gamma is your c value over your magnitude of your vector. And a, b, and c are just the x, y, and z components of your vector. All right, and then what I'm also going to show you is how you can write this vector in a different way now. Okay, so here's how we do this. We're going to say that cosine alpha is just the a component, so that's 1 over the magnitude of our vector. Well, let's just find that magnitude right now because we're going to need it for everything. It's just going to be 1 squared plus 5 squared plus 1 squared again. So our magnitude for this vector is 27, square root of 27. So cosine of alpha is just 1 over root 27. And I'm just going to write all these out first and then we'll evaluate. Cosine of beta, that's just your b value over the magnitude. Okay, see how once you have this magnitude, this is pretty easy. And then cosine of gamma is our c value over the magnitude. Okay, so notice that alpha and gamma should be the same thing because their cosines are the same thing. Okay, so now we're just going to type this into our calculator using inverse cosine of 1 over root 27. And so our angle is 78.904 degrees. And that is what alpha is and what gamma is. Okay. And then to find beta, we just do inverse cosine of 5 over root 27. And we get 15.793 degrees. And there you go. So those are called your directional angles. Now we're going to write V in the form V equals magnitude cosine alpha, cosine beta, cosine gamma. So take a look. This is actually pretty cool. Magnitude of V is root 27. Cosine of alpha is just this. 1 over root 27. Cosine of beta is just that, 5 over root 27. And cosine of gamma is just that. All right, now you're like, cool, what did we just do? Well, check this out. When you do root 27 times 1 over root 27, you get 1. When you do root 27 times 5 over root 27, you get 5. And when you do root 27 times 1 over root 27, you get 1. This is literally just a different way to write the vector. But if you distribute this root 27 to each component, you get exactly what we started with. Okay, which is good because it means we did it right. All right, so now let's go ahead and let's find the directional angles of the next one. Let's start off by finding our magnitude, since we'll need that. It's going to be 4 plus 9 plus 16, and that is square root of 29. Okay, so cosine of alpha is just going to be the 2 over the root 29. Cosine of beta is the 3 over the root 29. And cosine of gamma is negative 4. You do want that negative there over root 29. Okay, and then we'll just go ahead and inverse cosine and type all these in. Oops. So 68.199 degrees for alpha. And for beta, 56.145 degrees. And for, oops, I wrote, this should be gamma. Negative 4 over root 29. 137.969 degrees for gamma. Okay, and there are your 3 directional angles. And now we can rewrite vector v as the magnitude of root 29, and then cosine alpha, cosine beta, cosine gamma. And again, you can see that when you do the root 29 and you distribute, you get 2, 3, negative 4, which are the coefficients, the x, y, and j components. Or excuse me, I, j, and k components. Wrong set of letters there. All right, so there you go. That's how we find directional angles. I hope this was very exciting for you, and I hope you have a great day.